Hi, good morning, and welcome to DNN News. I'm your host, Josiah Bai, and today we bring to you a story on the ever-growing XV23 virus, a virus that reportedly exhibits vampiristic characteristics. We have special guest, Dr. Melendez, as well as Dr. Rodriguez here to answer some questions most people had on the newly found virus. For our very first question, would you be able to explain how the virus enters our body and infects us so fast?
The virus is suspected to initially enter the body through exposure to blood that already contains the virus. The virus is able to infect the body through the use of glycoproteins, which help to enter the cell. The XV23 virus uses glycoproteins such as proteoglycan as GPX23 and BP17, as well as a mucin-like glycoprotein. The glycoproteins are the ones that are primarily responsible for the entry into the red blood cells and into the stem cells. Once the virus XV23 has entered these cells, it binds to specific receptors. And one of the receptors that we have seen the virus use is the C47 receptor on the red blood cells. This receptor allows it to mimic the host's "don't eat me" signal, which as a result allows it to evade detection by the macrophages. And the B17 glycoprotein is what causes the sensitivity to light in a host. And by targeting the melanocytes, it interferes with the tyrosine receptor, the TYR, which blocks the production of melanin. Without melanin, the host becomes extremely sensitive to a UV ray from the sun. Finally, the mucin-like glycoproteins increase mucin production in the iris, which leads to the characteristic vertical slits in the host's eye. The change leads to better vision during the night, which explains the observed behavior of increased activity during the night. In addition to that, we see that the virus uses similar mechanisms to those found in malaria. Plasmidin E, PMB, disrupts the hemoglobin synthesis and inhibition of hematopoiesis in malaria. This is a shared effect that is also found in XV23. In addition to that, the virus binds to Band3 proteins, which promote the penetration into the erythrocytes and the release of its RNA. On top of that, the virus binds to P73 neutrophil receptors, 75 NTR in the brain. Replication within the brain consistently triggers the fight or flight response, which is why we can often observe increased aggression in infected hosts.
And after affecting so many people in San Antonio, many are asking, how does the virus reproduce itself?
Well, the XV23 virus follows both the lysogenic and lytic replication cycle. The cycle in which the virus is in depends on the host's developmental stage. In the early years, the virus exists in a lysogenic or dormant stage, in which it is only integrating its genome into the host's bone marrow. As the host progresses through puberty, hormonal changes causes the virus to switch into its lytic phase, where it begins to produce new virions. These new virions inhibit the production of new red blood cells. This is where we begin to see some of the characteristic signs of vampirism, such as increased growth in teeth and the seeking for blood from the host. Because of the previously mentioned inhibition of hematopoiesis, the host is not able to obtain enough iron, so it must seek blood from other humans. The lytic cycle of the virus also triggers sharp fangs found in vampires. We have seen that once the virus is inserted into the bone marrow, it replicates 1 every 2 days, but once it is in the lytic cycle, it replicates at a much quicker rate of approximately every 12 hours.
Following that, how does the virus interact with the immune system?
Virus XV23 has evolved sophisticated mechanisms to evade immune detection and manipulate the immune responses. During its lysogenic phase, the virus inserts its genome into the host cell, such as the RBCs, which are triggered without triggering the natural immune system. It mimics the CD47 signaling, which prevents the macrophages from identifying and destroying any infected RBCs. And this also renders antibody production obsolete. As the lytic phase progresses, infected cells release cytokines that trigger inflammation. The adaptive immune system mounts a response, but T cells fail to recognize infected cells due to the virus's ability to disrupt antigen presentation. B cells also become dysfunctional, producing ineffective antibodies that cannot neutralize the virus without also completely destroying the host's blood.
Knowing this information, what kind of responses does the virus trigger from our body?
Awesome question. The virus causes severe cardiovascular changes by disrupting hemoglobin structure and oxygen transport mechanisms. Blood pressure decreases due to vasodilation triggered by persistent hypoxia. The blood compensates by increasing cardiac output, resulting in tachycardia and irregular heart rhythms, causing a persistent activation of the fight or flight response.
After knowing everything you just told us about the virus, how can people protect themselves from this newly found virus?
So, what are some possible treatments? Well, one of the treatments for treating virus XV23 requires targeting its entry and replication mechanisms. Plasmidin V inhibitors show potential in preventing viral entry into RBCs. Also, gene editing techniques such as CRISPR and Cas9 may be used to exercise viral DNA from stem cells. Additionally, iron supplements might reduce blood cravings by restoring iron storages without the need for blood consumption. Preventative measures include genetic screening for newborns and public education campaigns to reduce stigma against the infected individuals. Thank you.